Hi, I'm Adi. Today I will help you understand the concept of Pascal's principle in fluid mechanics and in everyday life. Blaise Pascal, a French philosopher and physicist, released his treatise on the equilibrium of liquids in 1653, in which he studied static fluid concepts. A static fluid is one that does not move. When a fluid isn't moving, it's said to be in static equilibrium. We say the fluid is in hydrostatic equilibrium if it is water. The net force on any component of a fluid in static equilibrium must be zero, else, the fluid would start to flow. Pascal's principle, commonly known as Pascal's law, is a statement in fluid mechanics that a pressure change in one component of a fluid at rest in a closed container is transferred without loss to all other parts of the fluid and to the container walls. Blaise Pascal, a French scientist, was the first to state the idea. The force divided by the area on which it operates equals pressure. A pressure applied on one piston in a hydraulic system causes an equivalent rise in pressure on another piston in the system, according to Pascal's principle. When the area of the second piston is 10 times that of the first, the force on the second piston is 10 times more, even if the pressure is the same. The hydraulic press, which is based on Pascal's concept and employed in hydraulic brakes, is an example of this effect. According to Pascal's principle, the pressure changes by the same amount, mg/A, at all places in the water. As a result, the pressure at the bottom rises by mg/A. The total of the ambient pressure, the pressure owing to the fluid, and the pressure supplied by the mass equals the pressure at the bottom of the container. This formula expresses the change in pressure at the bottom of the container caused by the mass. We no longer need subscripts to identify the pressure change for top or bottom because the pressure changes are the same everywhere in the fluid. Hydraulic systems are used to operate automotive brakes, hydraulic jacks, and numerous other mechanical systems. Using Pascal's principle, we can deduce a connection between the forces in this basic hydraulic system. First, notice that the two pistons in the system are at the same height, hence there is no pressure differential owing to a depth difference. This formula simply expresses the pressure exerted by F1 on area A1. This pressure is transferred undiminished throughout the fluid and to all of the container's walls, according to Pascal's principle. As a result, a pressure P2 equal to P1 is sensed at the opposite piston. That is to say, P1 equals P2. However, we observe this formula because P2 equals F2/A2. Let us try solving these word problems. A 300 kg object is placed on a piston with a surface area of 3 square meters. The piston is connected to a secondary piston with a surface area of 2 square meters. Determine the force exerted on the secondary piston. First, let's write the given in the formula. Now, let's substitute the given values in the formula to find the answer. The final answer is 1962 newtons. Now that you have learned the concept of Pascal's principle, let's go deeper.